Good morning. Can you see the screen? Someone, please.
Yes, sir.
So, the last class we are talking about electromagnetic system. There are mainly two types of electromagnetic system. Where one is AC based electromagnetic system, and another one is DC based. So, AC based means at the output it will give us the AC output. Okay, that is inverter. That is inverter, and no, the DC based electromagnetic system is that controller or charge controller. DC based means at the output it will give us the DC, okay, or direct current. There, no, that inverter. If you talk about the inverter, that no, like at the output it will be giving us the AC output. Okay, and in AC based appliance system, there are no 80 to 90% efficiency you are getting. 80 to 90% efficiency we are getting, or for good inverter we are getting 90 to 95%. That is, there is a power loss in between 10 to 15%. So here the efficiency of inverter means how much the DC power is converted into AC power, isn't it? Okay. Uh, we are talking about the efficiency. And here, uh, suppose there is a put of 100-watt energy. 100-watt-hour energy. And in between, there is a inverter. Is basically input for inverter. Then at the output, how much we will get? This is input inverter. If the inverter is having capacity of suppose 85%, 85% efficiency. The output, how much we'll get? Then 85 watt hour energy. 85 watt hour energy will get. So there is a no, 15% energy loss while converting from DC power to AC power. So here this here it will be here the input is DC, it is this direct current. That one the curve it will be straight, and there for AC there will be a sinusoidal curve. At the output we are getting AC for inverter. Then like for our home or for our home appliances, how to find out the total power rating? Then that one, and accordingly we have to choose the capacity of inverter we are going to procure. Okay. Uh, then suppose how to find out the total power rating for our home appliances or for our home purposes, and there the inverter power rating generally it is given as, or it is generally given in terms of uh, either watt or kilowatt or no, on this voltage and current rating or kilovolt ampere. Okay? Voltage current, this is kilovolt and ampere rating. And then accordingly you can find it out. And suppose we are going to purchase some like good inverter. No, for good inverter, the efficiency rating is 90 to 95 percentage. Okay? And for typical inverter, it is 80 to 90%. Then accordingly you have to choose. Okay, suppose your requirement is your requirement is uh, suppose 900 watt is 900 watt. So losses will be there. You can calculate it, and the losses you have to add it. Losses you have to add it. Suppose typical inverter you are going to purchase, then 10% losses or 20% losses. 20% losses you have to add it. then accordingly you have to purchase it. The typical inverter ratings are kind of like 1 kilovolt ampere or 2 kilovolt or 5 kilovolt ampere. So this way we can find out from the market, or sometimes it is mentioned as like 1 kilowatt and 2 kilowatt or 5 kilowatt, so on. Okay. So this way we have to choose the inverter. And if you uh, talk about the price, uh, the price of inverter. So the price of inverter, mm, for average inverter, it is rupees 4 to 8 per watt. Okay. And for good inverter, it is almost double, 8 to 15 per watt. Okay. So accordingly you can choose, and here if once you purchase this one, no, like both inverter, and there the efficiency is good also. The if For good inverter, the efficiency is good also, which is 90 to 95 percentage. So there the energy conversion loss, it is minimum. That is, while converting from DC to AC, their losses is minimum. Uh, so overall, it will give us that economical benefit. And inverter, what does it do? That inverter, it converts from DC to AC. It converts DC to AC. And if we come over there in the battery or battery charger, what does it do? It converts AC to DC. So this is inverter, and this one, it will be controller or charge controller, isn't it? So now we'll move there in the charge controller, no? which converts which converts from which power to which power? Yes. What does it do? No, why we are using that inverter or charge controller? Why? What is the requirement of this inverter and charge controller? Can you hear me? What is the function of charge controller? Type there in the chat box. Other than conversion energy, what other functions of charge controller are? Okay, that is fine. It converts DC power to AC power. Other than conversion, what does it do? Why all the students are silent? Cannot you hear me? आप लोग अगर चुप रहेंगे, आई विल रिमेन साइलेंट ऑल्सो। तो सिर्फ हम ही बात करते जाएंगे और आप लोग कुछ भी रेस्पॉन्स नहीं करेंगे, कोऑपरेट नहीं करेंगे, ऐसे तो नहीं होगा। It should not happen. It is classroom. You are not attending any webinar. It is class only. So interaction it must be there, and you must respond over there. So all the students must switch on the cameras. Have to see whether you are attending the class properly or not. So uh, this charge controller, it gives us the DC power output. DC power appliances. So here, this solar panel, it produces DC power itself, and that battery, it stores energy in the form of DC power, and there the appliances are considering to be DC power only, like some no LED bulb, LED TV screen, or LED bulb, or some no laptop, or some BLDC fan. Okay, this is brushless direct current fan. BLDC, BLDC fan. So here all the no conversion systems are in the form of DC to DC only. Even although the solar panel is no producing direct current, but there must be charge controller also. No, for all the appliances, we cannot use no uh, the power directly there in the appliances. The power generated there in the solar panel, we cannot use directly there in the no appliances. Although that appliances is belongs to DC also. So there must be charge controller. Okay. So what are the roles of charge controller? It will extract it will extract maximum energy from the solar panel. Then it manages the battery also. It manages the battery also. How it's managing? So it will control the no that overcharge. Okay. Once there is a full charge, then automatically no it will disconnect, or that won't be no further charge that in the battery or energy storage system, and it provides the appropriate appropriate DC power to all the appliances. Okay, and here for the charge controller, the efficiency is 85 to 95 percentage. Okay, so it is always more than the inverter system, which converts the energy from DC to AC. Okay. So as we are generating power as DC there in the solar panel, and if we use the appliances as DC, then it is recommended to like recommended if one thing we are using there in the solar panel, but we are generating power that at the solar panel as DC power we are generating there in the solar panel. And if we use no all the appliances which are belongs to DC power, okay, then then we have to use charge controller over there. And it is also recommended no to use appliances as DC Okay, DC based appliances. Then we'll get some no more efficiency. More efficiency means their the power consumption by that appliances, it will be less. It will be less also. No, like while we are converting, just a minute, while we are converting, like DC to AC or AC to DC or DC to DC, that time power losses are there. Okay, and maximum power losses happens while we convert the power from DC to AC. There is a power loss around no 15 to 20%. DC to AC, this is inverter, there is a power loss of 15 to 20%. And while converting from AC to DC, this is charge controller. Here this is 10 to 15%. Then while converting from DC to DC, here at converting the power from DC to DC, here the power loss is minimum. There it is no 5 to 10 percentage. 5 to 10 percentage. Okay. So that's why we recommend to use DC appliances if the power source is DC itself. Here the exact value I'll tell you. This one. The exact value I'll tell you. Other than this, those are correct. This one I have little confused. Whether it is 10 to 15 or no something else like 15 to 18. So there in charge controller, so the input it will be DC and the output it will be DC also. And like the no typical size of charge controller are kind of like something 12 volt or 24 volt, 48, 120 volt, etc. Okay. You know the what is input voltage? It is the multiplication of that input voltage into input current and output. Uh, Sorry, the input power we are talking about. The power is nothing but the multiplication of B I, no, B into I. So if you talk about the input power, so obviously it will be input voltage and input current. So and at the output, it will be output voltage and output current. How much output we are getting. So in this way, we can know, like by measuring all the appliances, how much they are consuming the energy. Then this way we can know design the size of charge controller. Okay. So for charge controller, the efficiency is 85 to 95%. 85 to 95%. So there we are talking about this one, no? If it is 85 to 95%, so it is it will be 5 to 15 percentage. 5 to 15 percentage losses are there. Please note it down. And if we talk about the size, just a minute. The costing of charge controller. So it is basically lower than the inverter cost. Here the price is generally rupees 3 to 8, no, per watt basis. Okay. So we can say that one, no, the DC based solar system is high, higher in efficiency and lower in cost. Okay, higher in efficiency and the cost is less also. Why it is higher in efficiency? Because the conversion losses are minimum over there. The conversion losses are minimum over there. Okay, and typically, no, it is having low cost also. So if I ask you, like, why the DC based solar systems are, no, like, giving more efficiency than AC based solar system. No, AC based solar system, why? And what does mean by DC based solar system? Here in the solar panel, the power produced, the power produced, it is in DC form. It is in DC form. Okay. And no, if we use the DC based appliances over there, okay, at our home, that time it is known as DC based solar system. And here it is solar panel, it is DC only, no, by default. DC power only it generates. And there at the home, if there are AC appliances, okay, AC appliances, that time it is known as AC based solar system. Okay. Now, why this one is better? Why this one is better than this AC based solar system? Okay. So, can you write for like 5 sentences, 5 to 8 sentences from here for this question, like whatever we discussed today? So, from here, can you write 5 to 8 sentences? Why it is better? So, technology wise, you need to discuss it. Yes. So one thing here, like, if we talk about the appliances which are having higher efficiency, what does mean by higher efficiency? Yes, that is, it will take less energy. Okay, more efficient, more efficient appliance means it will take less energy. Okay. So in the beginning also we discussed about the different types of light sources. Like some bulb, then CFL, LED, isn't it? So suppose uh, we are looking for some like X amount of brightness. Okay, there if we use that bulb, okay, bulb, that the early days uh, which were coming with some 100-watt capacity or no 80-watt capacity, isn't it? Which is known as also like incandescent bulb. And after that, that CFL came. No, CFL bulb. This is for bulb, and then next came that CFL. For CFL, the power rating is generally like 20 watt, 30 watt, this way. Then uh, nowadays we are using LED bulb, and it is having very no less capacity. That is no, I mean less capacity means it will take less energy. But no, all of this it will give us the X amount of brightness. The brightness wise, its capacity is same. But here you see, no, its energy consumption rate is more. Energy consumption rate is more over there. Its price, its costing, it may be like 15 rupees, and its price, it may be 100 rupees. And its price it may be suppose 250 rupees. No, then uh, what is the benefit over there? So what is the benefit over there? Here we can see its price is more than other kind of no light sources. Why should we use this one? No. So here the total price or here the price is 15 rupees. It's very less. No, it's 10 and 250. But if we calculate the overall expenditure for suppose 1 year, then we can see that the overall cost it will be more over here for this kind of bulb because its energy consumption is more. Like uh, in a month, in a month, it may consume like 10 units. And here it will consume uh, like 6 units. And here it will be less, okay, 2 units. No, suppose like the per daily basis consumption, it is same over here, okay, for all those appliances. Suppose daily basis we are using this one for 8 hours, but here its energy consumption it will be more, then gradually it is decreasing. Then finally you just calculate it for next 2 years. Calculate it for 2 years. Then you can see the total cost, or total no the bill what we are paying, it will be less for this LED. Okay, so the total expenditure, it is the capital cost plus running cost. No, so here the running cost it will be less, isn't it? Here it will be less, and here it will be little bit increasing. Then here it will be decreasing more. And in this example, what I'm giving to you, like if we use another kind of appliances like some AC, refrigerator, no? There you can see the star ratings. The more star ratings means it will consume less energy. Okay, 5-star rating, then 4-star rating, 3-star rating. For 3-star rating appliance, the capital cost, it will be less obviously, but the running cost it will be more. It will be more than other 4-star rating and 5-star rating appliances. And in DC based appliances, there generally star rating it is not giving over there. Okay, the star rating is not giving generally over there, but its energy consumption is less. It is lesser than other that AC based appliances. Okay. So we have to use that higher star rating appliances, although its cost is more, but it is suggested to use high star rating appliances. And that star rating, who decides that star rating? That manufacturers, they cannot, no, they cannot decide. The manufacturers of that appliances, they cannot decide. So first of all, no, it will be decided by the Bureau of Energy Efficiency. Okay. So for this kind of equipment or technologies, the star rating will be 5 or 4 or 3. Then they can mark it over there. They are in the appliance. No, after that Bureau of Energy Efficiency. This is centralized basis. Centralized basis. Uh, then okay. So that's all for today. And Devesh, have you taken the attendance?
Yes, sir.
You can switch off your cameras. Now, one more thing. Uh, like in the next week, and that is on Tuesday, while joining the class, so there you just come with your that progress of mini project the next week. Like what you did, you have to explain. Okay. So if you're learning software, then someone of you have to explain it, and I'll ask some summary kind of that in the Google Classroom as an assignment. I may ask you write down the brief, write in brief what you have learned about software or the relevant papers or the methodologies or some like algorithms kind of. So I may ask you by Sunday evening. So just you prepare accordingly. And no, recently I have uploaded few wind energy related books that are in the Google Classroom. Around 6 to 7 books I have uploaded. And solar energy related book also I have uploaded. You can go through that one also. You'll get so many informations over there, that books. Okay, then that's all for today. So thank you all. Now you can leave them.